Let's explore volume drivers and plugins, which are advanced storage backend options. These extend storage capabilities beyond standard file systems, utilizing specialized drivers and plugin architectures. Volume drivers are software components that provide an abstraction layer between containerized applications and the underlying storage systems. Key characteristics include storage backend abstraction, a pluggable architecture, runtime configuration, and cross-platform support. Let's take a look at some built-in volume drivers. The first is local, which is the default driver that stores data on the Docker host file system. The second is tmpfs, a temporary file system stored in host memory for fast, volatile storage. The third is bind, which is a direct mapping between host directories and container paths. And the fourth is overlay 2, which is a union file system for layered storage with copy-on-write semantics. Now let's see some third-party volume plugins. Some popular plugins include AWS Elastic Block Storage, Azure File, Google Compute Engine Persistent Disk, NetApp, and Portworx. Key benefits of these plugins include cloud storage integration, enterprise features, high availability, advanced security, and performance optimization. Here are the installation commands to install and enable a plugin. To install a plugin, use Docker plugin install, followed by the store, plugin, and tag. To enable a plugin, use Docker plugin enable, followed by the plugin name. The installation process involves downloading the plugin from a registry, verifying the plugin signature, configuring permissions, and enabling the plugin service. Here's how to configure a driver during volume creation. The command is docker volume create, followed by the driver, which is local in this case. Then specify the type, such as NFS, and options like the address, which is 192.168.1, and the device, which is :/path/to/directory, and finally the volume name my volume. Configuration options include specifying the volume driver with the driver flag, setting driver-specific options with the opt flag, and adding metadata labels with the label flag. Let's see some advanced storage backends. The first is NFS, or Network File System, for distributed storage access, offering cross-platform compatibility, high performance, and shared access. The second is CIFS, or SMB, which is the Windows File Sharing Protocol for enterprise environments, providing Windows integration, authentication, and security. The third is iSCSI, which is block-level storage over IP networks for high performance, offering raw block access, storage area network connectivity, and enterprise-grade features. The fourth is object storage, which is S3-compatible storage for scalable cloud applications, offering unlimited scale, REST API, and cloud-native capabilities. Here are some best practices for implementing volume drivers and plugins. First, test plugins in a development environment first. Second, monitor performance metrics. Third, implement backup strategies. Fourth, use the appropriate driver for the workload. Key considerations include security and access control, network latency impact, plugin compatibility, and data persistence requirements. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.